Can you hear me? आवाज clear है?
Yes, sir.
Yes.
ठीक है. अच्छा चलो ठीक है, यहाँ से हम start करें कि weak acids, right? So we had to discuss weak acids. के what were weak acids? वो पता ही है आपको कि the ones that partially ionized, ठीक है, or they don't fully dissociate. ठीक है, that's what weak acids are. And the last time what we were discussing, since we are dealing with equilibria, chemical equilibria, I told you that the problem with strong acids का हमने last time discuss किया था, वो थोड़ा सा revise करने कि we said that when you have a strong acid, right? कितने के strong acids, this one. So when you have a strong acid, to figure out the quantity of H plus 1 concentration, that's very easy. क्योंकि उसे it's going to fully dissociate. If this is 0.0001 mole per dm cube, then H plus 1 would also be 0.001 mole per dm cube, ठीक है? So they would all be 0.001 mole per dm cube, and that's quite easy. So pH nikalna, that's also very simple. Okay, you're going to take the log, and this is what 10 power minus 3. So the log comes out to be 3. That's your pH. So it's pretty straightforward in the case of strong acids. So now what we're going to discuss is weak acids. So weak acids का हमने discuss ये किया था कि when you have weak acids like organic acids, the problem with weak acids is that they partially ionize. They're going to produce ethanoic ions and H plus 1 ions, but they're going to weakly ionize. So if this is 0.15 mole per dm cube, then your H plus 1 is not going to be 0.01 mole per dm cube. It's not. Okay, this is not going to be 0.01 mole per dm cube, and the reason for that is it's not going to fully ionize. So very little amount is going to ionize. So if you have 100 molecules, maybe 2 or 3 would actually ionize. So it's harder to predict what the amount of H plus 1 ions is. And if you don't know what the H plus 1 concentration is, you can't figure out the pH, which is the negative log of H plus 1 concentration. Okay? So, but what you can do is, okay, all weak acid dissociation, that's an equilibrium reaction. And since it's an equilibrium reaction, it will have an equilibrium constant, which is product concentration divided by a reactant concentration. Okay, that is known as the dissociation constant. Okay, यहाँ पे I didn't write the word, but I'm going to say that this is, okay, this over here is your dissociation constant. And that's basically the equilibrium constant for a weak acid. Achha, now before we move on, the first thing is we're going to talk about weak acids, right? So remember, there are two types of weak acids. There are organic acids and there are acid salts, okay? Achha, organic acids, all organic acids, or any acid that contains carbon, that's normally a weak acid. So chemistry mein, in A-levels chemistry, the organic acids that are weak acids, they are carboxylic acids. ये पूरा एक chapter होगा उसके अंदर organic के अंदर. So we're not going to go into details. You've got phenols. Now most of you don't know what a phenol is. When we study organic chemistry, we will talk about this. Achha, and then you have achha, and then you have there's a alcohols piece. Sometimes alcohols are also, I mean, they're extremely weak. You can't even call them acids. But anyways, all of that detail will take place in बल्कि कर लेंगे थोड़ा बहुत ना हम इसमें कर लेंगे. We'll discuss weak acids. Now the other thing is, what's an acid salt? What is an acid salt? Achha, so an acid salt is that it's a salt formed when an acid is partially neutralized. It's partially neutralized. So it still has H plus one ions. So for example, I'm going to tell you what a salt is, or a complete salt is. You've got HCl. Why is HCl an acid? Because it's capable of producing H plus one ions. You get rid of those H plus one ions, replace it with, let's say, sodium. So you've got a salt, right? So that's a complete salt. This is not capable of. So if you have a complete salt, मतलब सारों को पता है NaCl is a salt. So if you have a complete salt, it's completely neutralized, not capable of producing H plus one ions because there are no H plus one ions. Producing H positive ions, it has no H plus one ions, so how can it produce H plus one ions? I said, but when you have a diprotic, it's also known as dibasic. So, for example, if you have a diprotic or a dibasic acid, it's an acid that has two H plus one ions. So, for example, if you have H2SO4. So, what could happen is that you could get rid of both H's and replace it with sodium. So, it's going to be Na plus 1 and SO4 minus 2, and it's going to be Na2SO4, right? So, that's again a perfectly neutralized acid. It's a salt. So, that's a salt. But sometimes what could happen is that only one of the H's gets neutralized. So you've got HSO4 minus 1 and Na plus 1. So the salt that is formed, that's NaHSO4, that still has H plus ions, and that's your acid salt. So यहाँ पे ये कि NaHSO4 can release or produce H plus one ions. Hopefully everyone knows कि when you release H plus ions, that's what an acid is. ठीक है? So that is what an acid salt is. And similarly, you can have, so normally acid salts exist when you have diprotic or dibasic, or sometimes you have triprotic, tribasic acids. तो एक वो example कर लेते हैं. So if I have triprotic acids or tribasic, for example, an example is H3PO4. So it can have two acid salts. I mean, one is that it can have a salt where all the H's are gone, so that's your salt. Or it can have two Na plus one ions, one H plus one ion, and then there is PO4 minus 3. Or one Na and two H's and PO4 minus 3. Okay, so sorry, two H's. So these would be your acid salts because all the H's are not neutralized. Okay, is this thing clear? Rumesa clear है? Meral, Ibrahim clear है? Ala.
Yes. Yes, sir.
So ठीक है,
Yes.
ठीक है, just remember what an acid salt is. Just a brief, a little bit further detail about what acid salts are. Okay, now remember, everyone says that phosphoric acid. इस पे हम वापस आते हैं बाद में, पहले वो कर लेते हैं. अच्छा, so Ka, this is the acid dissociation constant. So all acids, whether they're acid salts or whether they're organic acids, they all dissociate in kind of the same way. Okay, acid by definition is what? It's a proton donor, right? So you've got ethanoic acid, it will dissociate, and what will happen? It will produce some random negative ion which we don't care about, and it will produce an H plus one ion, ठीक है, which is what makes it an acid. पानी के अंदर जो होगा वो H plus one concentration would increase. If you have an acid salt, like for example, I have the HSO4 minus one ion, what will happen in that case as well? That will also dissociate in exactly the same way. It's going to produce an SO4 minus 2 ion and it will produce an H plus 1 ion. Okay, so anything that's capable of producing an H plus 1 ion, that's what an acid is. This is how the dissociation would look like. So if I have NH4 plus 1, again, it has H plus 1 ion, so it is capable of, I mean, it's going to produce ammonia and it's going to release one H plus 1 ions. Now, no matter what the acid is, the equations are kind of very, very identical, and they all have this H plus 1 being released. So it's basically the same exact format. So it doesn't really matter. So what we can do is we can generalize or write a general equation, which is that all acids have this formula that they have an H plus 1 ion followed by, I mean, attached to something. Okay, we don't care what that something is. It will dissociate. And when it dissociates, it will produce some random negative ion, or maybe it's not negative, TK, but it's going to produce some random thing, and it will release an H plus ion. So that's the most generic way of describing what acid dissociation looks like. TK, this is how it. So this is how it looks like. TK, that's how acids dissociate. That's one thing. Achha, but then there's another thing, which is that early on I told you that in aqueous state, I told you that H plus one actually doesn't exist. What happens is, बहुत पहले I told you that when we were talking about dissociation, I told you one thing, that what we call this H plus one, किधर गया? कहाँ गायब हो गया? एक second. What I told you was, what you think this H plus one is, there is no such thing as H plus one. What happens is that when H plus one ions are produced in water, especially in aqueous state, this H plus 1 goes and combines or gets attracted to the negative lone pairs of the water molecules, and it ends up forming a dative bond. So what you think is H plus 1 aqueous, it's actually not H plus 1 aqueous, because there is no H plus 1 aqueous floating around. It's an H plus 1 that it gets datively bonded to water molecules. So the actual equation is that there is no H plus 1 aqueous. That H plus 1 aqueous would combine with water and it will actually form H3O plus 1. ठीक है, ये बहुत पहले start में I told you this thing. So I'm going to go back, and what I'm going to do is I'm going to write the more detailed equation. But most of the time, this equation is the one that works. Okay, so they would be using both equations, but I'm going to write the detailed equation. So what happens is that this HX is going to release an H plus 9, and the water is the one that's going to accept that H plus 9. So the H plus 1 gets released, and that H plus 1 aqueous combines with the water and it becomes H3O plus 1. So that's your more detailed version of acid dissociation. Okay, so this one is the simplified one. So all your life you've studied about H plus 1 aqueous. Now I'm telling you that the H plus 1 aqueous is actually H plus 1 combined with water, and it is actually H3O plus 1. And this is the detailed version. ठीक है, ये चीज clear है? Is this clear? Ala Minal, is this clear to Ibrahim? Clear?
Yes, sir.
Yes.
Yes.
Yeah, sir.
Okay, so now all acids are going to dissociate in exactly the same way. Except what happens when you have a diprotic acid. Okay? So remember, this is a generic equation. And I'm telling you that all acids will produce exactly one H plus one ion. Okay? All these acids, they will produce exactly one H plus one ion, right? So that's your generic equation. I said, now what happens if you have a diprotic acid? So what about diprotic acid? How do they dissociate? So their dissociation is exactly the same. For example, you've got sulfuric acid. Now, what you need to understand is that sulfuric acid is not one acid. It's actually two totally different acids. There are actually two dissociations. They have two dissociations exactly the same as the ones that are described above. So it's actually totally two different acids. What happens is that it will release one H plus one ion first. So what are you left with? You're left with HSO4 minus 1 and it produces NH plus 1 ion. Okay, that's the first dissociation. What is the next one? Then this HSO4 minus 1, it still has an H plus 1 ion. So what happens now is, okay, that HSO4 minus 1, it is going to dissociate further. And it will be left, you'll be left with SO4 minus 2, and there's going to be another H plus 1 ion that is going to be produced. Okay, so there is dissociation 1. And then you have dissociation number 2. Okay, so you're going to think of, and both these acids, they behave differently. Sulfuric acid is going to undergo the first dissociation, and it will form this negative ion, and it's going to produce H plus 1 ions. And then this thing will undergo the second dissociation. Both of these things are actually totally different species. The first dissociation is the one that is easy. Okay, this one is the one, now listen to this carefully. This one is the one that's going to be easy. The second dissociation is going to be very, very difficult. Why? Because it would be very hard or difficult for HSO4 minus 1 ion to lose an H plus 1 ion because it's now a negative ion, right? Negative ions actually attract H plus 1 ions. So it's going to be very difficult for them to actually lose another H plus 1 ion, okay? So the first dissociation is going to happen very easily. The second is the one which is going to happen very weakly. So actually क्या हो रहा है कि the first dissociation, this one is actually a strong acid or it's behaving as a strong acid. And this one over here is actually behaving as a weak acid. So remember, you have to relearn this, which is that you've always thought that sulfuric acid dissociates in this way, that it's a strong acid, it produces two H plus ions and one SO4 minus 2 ions. So keep this in mind. This is not how it happens. Okay, you have a first dissociation. That's easy. It's easy for the neutral molecule to lose an H plus ion because it's not going to attract it back. And then the negative ion that's formed, that's going to lose the second H plus ion. But for it, it's going to be very difficult. ये बात भी clear है? Is this clear? How acids will dissociate, diprotic acids will dissociate stepwise. Clear about? Is that
Yes,
clear?
sir.
Yes, sir.
Achha, so remember the format is exactly the same, the way I described above. Okay. So every dissociation, only one H plus one would get removed. Okay, so keep this in mind. You'll have an acid, it will produce some random ion and it's going to produce an H plus one, but only one. Okay, not two. That's not going to happen. Okay, so similarly, if you have a tribasic acid, So remember, in the paper, they can come up with any example, but the concept is exactly the same. So if you have a tribasic acid, for example, phosphoric acid, well, it's going to produce H2PO4 minus 1, and it's going to release 1H plus 1 ion. Then what happens? H2PO4 minus 1 goes on to release another H plus 1, so you're left with 1H. So then what happens? This HPO4 minus 2 then goes on to release the third H plus 1. So now you have PO4 minus 3, and you have, so 3 dissociation. Dissociation 1. You have dissociation 2, and you have dissociation 3. So there are 3 totally separate equilibrium reactions. And based on that, there'll be 3 different equilibrium constants. There'll be Ka1, there'll be Ka2, and they will be Ka3. There'll be 3 totally separate dissociations. You see, for sulfuric acid, you're going to have 2 dissociation constants. There's going to be Ka1, which is your equilibrium constant. There's going to be Ka2. So for dibasic, tribasic acids, you'll have 3 totally separate. And the same thing, it's going to be, what will happen is, the dissociation would become more difficult as the negative charge on the ion increases. It's going to become more and more difficult as the negative charge of the ion continues to increase. That's ये clear है सारों को? Is this clear?
Yes.
ठीक है. अच्छा, coming back to dissociation constant, right? So remember, this is your generic equation. I'm going to rewrite this. What is it? It's Hx dissociates, and it becomes x minus 1 and h plus 1. So what is your dissociation constant Ka? It's basically what? It's your product concentration divided by your reactant concentration, right? So, बल्कि इसको थोड़ा सा मैं डिटेल में कर रहा हूँ कि where were your but let's start with this one. This is your Ka product concentration divided by reactant concentration, which is going to be what? It's going to be x minus 1 concentration times h plus 1 concentration divided by your hx concentration. So that's your K expression. Okay, we've got a K expression, which is going to be modified a little bit. Why? Because the x minus 1 concentration and my h plus 1 concentration is going to be exactly the same. Because one of this is going to be produced and one of this is going to be produced, right? So they're both going to have exactly the same value. Okay, when the acid dissociates, both of them are going to be produced in equal amounts. So if this and this are exactly the same, what I can do is I can modify the expression and I can write it as K would actually be. So remember, if these two ions are exactly the same, their concentration is exactly the same. So instead of writing x minus 1 and h plus 1, I can write h plus 1 squared. Because x minus 1 concentration is also equal to h plus 1 concentration, so I can write h plus 1 squared, and the denominator is hx, which is basically my acid concentration. So what I can do is I can modify the expression, and this is my new K expression. Okay, is this thing clear?
Yes,
Yeah.
sir.
अच्छा इससे आगे अब ये K, we know what K is, and you can use this. अच्छा, I'll also make the expression for the other one. The more detailed equation was this one, right? Just to show you. Although that is enough, most of the time you're going to use that. But the more detailed dissociation equation was this one, which was that you had x minus 1 and the h plus 1 went and combined with water and formed H3O plus 1. So sometimes you're going to see a slightly different version of the expression, which is that they'll say this is Kc, which is x minus 1 concentration times H3O plus 1 concentration divided by the reaction concentration, which is what Hx and H2O concentration. But remember, the trouble is that water in aqueous state or water is in large excess. So water concentration is considered to be a constant. So you don't write water in the expression. So if you kind of rearrange and put all the constants together, it's going to look like this. It's going to be Kc times water concentration, which is also constant. Because remember, everything is happening in aqueous solution, so water is in very large excess, and if something is in very large excess, the concentration is not going to change, and you'll be left with x minus 1 and H3O plus 1, or नीचे क्या आ रहा है, that's Hx concentration. But the rest is pretty much the same. The x minus 1 and H3O plus 1 have exactly the same concentration. This thing over here would be called Ka, which is going to be H3O plus 1 squared. You can remember this thing and this thing will be exactly the same. So you're going to write H3O plus 1 squared, and the denominator is your acid concentration. So we just wasted time deriving the same exact expression. TK, which is this one. It's but just so that you don't get confused, remember most of the time they'll be dealing with this. You'll be dealing in past papers with this simpler version. It's gonna they don't include water, and you get this expression product concentration divided by reactant concentration, which is going to give you H plus 1 squared divided by the acid concentration. And sometimes they're going to include water in. Sometimes TK, not very often. So don't get confused. It's still the same expression. You don't write water in the expression. It's product concentration. H plus 1 ki jagah na, what you're going to write is H3O plus 1, x minus 1, right? And you're going to remove the water from the expression. Basically put all the constants together. And that's your K expression, which is kind of exactly the same. ठीक है. अच्छा, ये clear है? Is this clear to everyone?
बात तो सुन के क्या कहता है
अच्छा, ये clear है?
ऑलरेडी क्लास
You still have a mic on it. So, Hala, is this clear? अच्छा, आगे the next thing is.
Yes, sir.
ठीक है. अच्छा, कितना time है? So the next thing is how to use this. So remember, we're just going to use the simpler version, which is this one. most complicated version when I just did that because sometimes in past papers you might end up seeing that. So don't get confused, it's exactly the same thing. I said, so we're going to use this. Now the important thing is, okay, while you're doing this, the important thing is that you have एक second है ना. अच्छा, वापस. I said the important thing is to understand what K stands for. It's an equilibrium constant. If you have a larger value, that means, what does that mean? It means you have more products forming. This numerator has a bigger concentration and your denominator has a lower concentration. That means you have more products forming. If K is large, that means it's a strong acid. That means you'll end up with more dissociation and more H plus ions are going to be produced. Vice versa, if you have Ka and it's got a small value. So what does that mean? That means you have a weaker acid. And there is going to be less dissociation in that case. तो ये दो चीजें, ठीक है? Keep this in mind. अच्छा summary करें क्योंकि we'll probably end it over here because फिर वो नया मतलब नया chapter तो नहीं. We'll have to start using this. We don't have enough time for that. So summary है कि every weak acid has a dissociation constant and that kind of tells you whether that acid is strong or it's weak. तो पूरे tables बने हैं where every acid that you think of has a dissociation constant. And like any equilibrium constant, it only changes with temperature. It actually increases with temperature. So remember, higher temperature would mean more dissociation. The acid is going to dissociate more if you have a higher temperature. So yeah, बाकी we'll continue tomorrow, ठीक है? We're out of time. अब इतना time नहीं है कि हम बैठ के ना इसको बहुत ज़्यादा further discuss करें या question कर सकें. So we'll continue tomorrow. और इसके फिर questions करने हैं basically बस, ठीक है? चलिए, okay everyone. Take care, Allah Hafiz.